Okay, I think we can slowly start. Good afternoon to everyone. Welcome to the invited talk by Dr.Monika Kuffer with title Monitoring Environmental and Physical Deprivation in Urban Areas, Advancements in Earth Observation. Dr. Monika Kuffer is an associated professor at the Faculty ITC of University of Twente, Netherlands. Her research focuses on remote sensing, urban spatial analysis, SDGs, urban equality, and urban environments. She's co-chairing a network on deprivation area mapping, IDEAMAPS. She's working on several research projects on urban deprivation and environment, SLUMAP, IDEATlas and ACCOUNT. She is a project coordinator of 2 NUFFIC-funded training grants, IDEAMAPSudan, Capacity Strengthening for Gender Responsive and Sustainable Urban Development, and Data for Human Rights, Nigeria. She is part of the steering committee of the Joint Urban Remote Sensing event, the Dutch representative of the European Association of Remote Sensing Laboratories, and the SIG chair for developing countries. She is also a member of the steering committee, Earth Observation for Sustainable Cities and Communities Toolkit. She has more than 80 publications. So today's talk is also being recorded, so please turn off your cameras and microphones. We will allow questions through the chat, and I will address them to Dr. Kuffer after the talk. So Dr. Kuffer, the floor is yours.
Well, thanks a lot. And first of all, thanks a lot for the invitation. And I have been last year at your lovely place during the EARSeL conference at the ERATOSTHENES Centre of Excellence in Cyprus. And it was a great experience. And I was very pleased to get your invitation and talking on a topic which I know that in the project EXCELSIOR, you're looking to the Mediterranean region, the Middle East and North Africa. And I will extend a bit on other parts of this planet, more also to the southern part of Africa, the sub-Saharan Africa, which I think you're also at least partially working on. And so happy to talk about deprivation, inequality, which I think is a massive challenge and an important topic of this planet. Let me switch on my presentation. Sorry. It's stuck with too many things open. Oh, here it comes. I hope the presentation is coming and you can view the presentation. I hope my audio is also clear.
Yes.
So great. And thanks for joining. So I also look forward to get some questions towards the end of the presentation. Also see on what topics you're working and how monitoring environmental and physical deprivation in urban areas using observation also relates to your work. So we'll talk about a lot on the mapping, but also on the diversity and also challenges on mapping using Earth observation, but also a lot on how to bring data beyond our very narrow community of Earth observation scientists. And making data relevant, for example, for global challenges, global questions, be it, for example, in particular the SDG and monitoring the progress of SDGs, but also bringing data into communities actually who need data on deprivation, in bracket poverty, multidimensionality of poverty. I will also explain the concept of deprivation in few slides. And yeah, basically also linking data to local actions. So at various scales where actually Earth observation data are very relevant. And I think we have a massive capacity and potential, but you often don't go across the borders of bridging and making data available to stakeholders and users who actually would need such information to inform policy. I don't want to dwell too long on myself because Eleni gave already a fabulous overview of what I'm doing. So just in a nutshell, so I'm let's say, and I was trying to map all the projects I'm doing in relation to the different SDGs, and there's obviously a strong link to SDG 11 on sustainable cities, making data available to support monitoring at a global but also at a local level, but also a lot of other related SDGs which relate, for example, to climate action in the intersection of deprivation and vulnerabilities of the most deprived communities in terms of the increasing threats of climate change, be it floods, be it storms, sea level rise, etc. Of course, also the linkage with poverty, inequalities in general, which is driving my research. And you will see also the presentation will be giving a broad overview where is the potential of Earth observation to respond to these global challenges. But also the technical sort of challenges we still need to overcome, but also our communication challenges to a broader community to make data available and accessible to users. One of these works I'm involved with many colleagues are making Earth observation data available, and also like a call in case you are interested and have readily available data sets that we respond particularly to SDG 11 or more broadly also to the new urban agenda. We are in the process. It's now a finished product, but it's a continuously evolving product. We developed Toolkit, an Earth observation toolkit, to make Earth observation data being documented. So the data will first be screened, or whether they are fair data, whether they follow the fair data principle, and then they are well documented in a toolkit that enables users which are not typically Earth observation users, but for example, local governments, national governments, ministries, but also NGOs, to easily access the data we are producing as Earth observation community to support evidence-based policy. And that's something which I think, and it's a call also to the Earth observation community to channel, but also like always a reminder to myself that, let's say, we always talk in our publications in the end, oh, this data are relevant for local stakeholders and actors, but we never think about how can we make them accessible to them, because there's a big technology bridge gap, and we need to bridge this gap. So think about how to make this data more accessible to a larger community of users. And this is one of the first tries to make SDG 11 relevant data more accessible. So feel free to reach out. So what I'm talking mainly are in my talk is like a network of projects, which is around IDEAMAPS, which is stands for Integrated Deprivation Area Mapping. And it links to the question that we have been producing data on areas which you commonly refer as slums, informal settlements, but also in general deprived areas, which you also find not only in the global south, but also in the global north, areas which are deprived in terms of living in environmental conditions, physical conditions. And we have been producing a lot of data individually, but we never managed to produce a relevant global data set that can be, for example, supporting SDG monitoring, but which are also relevant, for example, for a broader community. We had last week, we have been at Crete with our friend and colleague Nick. He organized a joint urban remote sensing conference, and we had Karen Sito giving a keynote from IPCC and stressing heavily that the community, the climate change community, desperately needs a layer that shows the most deprived areas in cities to think about particular climate action for these most vulnerable communities. So in this network of projects, we are trying to make data, modeled data, available, but also thinking about the challenges, privacy challenges, ethical challenges, how to make such data available that we not produce more harms to vulnerable communities, but making data available for supporting local to global action. And you will see that some of the the projects industries relate more to the data models, like the data ecosystem in IDEAMAPS, how to make a model system and how we are building a model system. But IDEAtlas is looking very much to the use of Earth observation data to produce maps on deprived areas, while, for example, other related projects are, which also will come back, are local implementation with policymakers, like in Sudan recently done, unfortunately now stopped because of the conflict, and aspects of how to make data also beyond the the local government, the government actors available to NGOs, which looks to the data for human rights to provide communities with an understanding and training and capacities of using data and simple data for also negotiation processes with local governments. But now I've been talking a lot about what is deprivation. So it goes back to the discussion and the definition of UN Habitat in the indicator SDG 11.1.1, where they talk about slums, informal settlements, in inadequate housing. So slums in a UN Habitat perspective is a household level concept, which is measured by household level statistics, which is full of uncertainties because of reporting gaps, because of also inconsistency in reporting between countries, data gaps, and all kinds of other uncertainties in this data set. So UN Habitat is very interested in developing an Earth observation-based indicator that relates to the concept and the definition of UN Habitat of informal settlements, which is an area level concept, which looks to the specific deprivation aspects of an area. For example, an area being not accessible, an area being possibly contaminated, an area being a hazardous location, etc. Our concept of deprivation includes both aspects, the household level aspect as well as the area level aspect of deprivation, which sort of relates to each other, but are not necessarily similar. You will find slum household outside informal settlements, and you will find non-slum households in informal settlements, which brings a complexity into the picture, as well as typically, and that's also what you, when you see and go to the list of publication on slums, informal settlements over the last years, a lot of the studies are done from researchers from the global north. Of course, also global south researchers are doing working on this topic, but there's often sort of an incomplete understanding of the complexity of deprivation and what data are actually needed on the ground. And that's few ground photos and an example of an deprived area in Sudan. So all relate to the same place, these photos, and the complexity and the diversity of aspects of deprivation on the political dimension, which relates to the previous situation of the military coup in Sudan, and the struggle of community to act against the political regime, which was at that moment a military government. The environmental conditions, which are very harsh, and often in many cities, the massive problem of waste, which is often not fully understood by global north researcher, and also the sort of not inclusion of mapping of waste collection, and the need of visualizing this massive problem on maps, but also that in deprivation model that we should not only map what is lacking of an area, what are the shortcomings of an area, but also what are the assets of the area. Here as an example of a public library built in this area. So all should be combined, the Earth observation-based mapping, with a more detailed, localized understanding of what are the assets, but what are also the aspects of deprivation in those areas. From our Earth observation view, in this example, you see on the right a drone image of the city of Nairobi. You see often this clear-cut boundaries, which is a great example, but often the situation is also more complex. But to a certain degree, we can relatively easily map such areas and the difference between the formal areas and the informal areas based on Earth observation, building a base map to relate to how many inhabitants are living in such areas, and making a sort of city level, a national level model on the scale of the problem and the scale of people who are exposed to environmental conditions. You see on the left, like the massive waste accumulation in Lagos, and I come also to some mapping examples of this, or also the struggle on the ground, like this gentleman. I've been with him on this photo, so I took the photo, and we have been maneuvering through an informal settlements with people of disabilities, which is done in Lagos on skateboards, because that's the only way of mobility for people of deprived areas. So there are massive sustainability challenges on this globe. Cities are growing rapidly, like here the case of Khartoum. Now, of course, there's an opposite trend because of the conflict. A lot of people have left the city. I also shown view on how much of the area is basically now not connected anymore with electricity. But generally, the challenges are massive, and cities are rapidly growing, driven by climate change, by displacement, by economic opportunities, by also the loss of agriculture, livelihood strategies. A lot of the also related problems relate, particularly in the peri-urban areas, are land management issues, inequalities of access to land, also the transition between the formal land tenure system and customary land tenure system, where typically also the poorer population is losing a massive inequality also in gender. Like in Africa, less than 10% of the land is owned by women, while most women are basically they're the main actors in agricultural productivity in Africa. So there's massive inequalities, which we, I think, should visualize always in the combination of Earth observation data in combination with local and geospatial data sets. Another aspect also relating to Sudan, and that's also in the project, we have been building up a first open geodata node to make data accessible that relate to deprivation. Data are typically hidden in ministries if data are available, so they're not, even different ministries don't know which data sets are available. So we have been using and collecting data that relate to deprivation, gridding them to not show the exact boundaries, which has to do also with privacy issues, and making data sets available for local actors to be at least aware what data are available that can support deprivation analysis. We have been hoping to extend this from our pilot in Khartoum to other parts in Sudan, knowing that particularly not only the major cities are growing rapidly, but also the secondary cities are rapidly growing, and that's an often very overlooked topic in Earth observation, the massive development of secondary cities, where most of the Earth observation studies always focus on the major cities because of easy access, of base data availability. But I think we need to leave this trajectory, and what you see on this map that and the red dots, maybe not clearly visible, show that particularly the secondary cities are massively growing. And that's something which we totally overlook as Earth observation community. And this has to do with a lot like in Sudan, with the relation between push and pull factors, where typically also the push factors from rural area into the secondary cities are very much dominating because of the context of climate change, economy, and political conflicts and armed conflicts. What we're doing in IDEAMAPS, and that's what you see on the right, we have been developing a model and a conceptual model on what defines deprivation. Deprivation looking to the physical deprivation, but also environmental deprivation, socioeconomic deprivation aspects. And we have been clustering this into these 9 domains of deprivation, like housing, which is on the household level deprivation, or deprivation which relates to an area level perspective of deprivation. So how an area is contaminated, for example, by massive waste accumulation, but also the morphology of an area which is causing deprivation, like high density, not availability of open spaces. But and then the last level is how areas are connected with the rest of the city in terms of infrastructure, services, etc. And we are filling all these domains with data, with indicators, some of them coming from Earth observation informed data sets, other from geospatial data sets, either open data sets, municipal data sets. So we are compiling massive amount of data to visualize the variations of living conditions, like, and I will come back later to some examples. So how much more are deprived settlements exposed to floods? How are the living conditions? How are the health conditions in those settlements? In the end, we are aiming to produce city-level maps, what you see on the left, showing deprivation, gridded deprivation systems from the least to the most deprived, which can be locally classified, locally relevant, classified into slum, non-slum, informal, non-informal areas, and combined with population data sets to make an estimate about how many people living in the most deprived areas. We combining this with Earth observation-based models within IDEAMATLAS, because often in many cities you don't have high-quality data that inform all domains. So we are also looking into how much only Earth observation-based model can predict the variations of living conditions, and there we typically look to the combination of open and freely available data sets to be making the model scalable. Combining Sentinel-1 and Sentinel-2 data with auxiliary geospatial data, which are typically open data, to train multi-stream FCN-based algorithms to produce city-scale metrics about informal settlements / deprivation. Indicators which are flowing into these data sets are, for example, an important aspect is nightlight. Often nightlight images are used in relation to mapping the urban extent, but particularly in the Global South questions, areas which are not connected to the electricity grid or which have instability of the electricity grid are those areas which are the most deprived areas, which has issues about economic development, education, kids sit in the night without access to electricity, to learn, to study, but also has a gender dimension. Often women in these areas feel very unsafe to go out after sunsets, which often happens very early, the sunset in tropical regions. As well as you can use nightlight data to get a first impression of a extreme crisis, like in the case of Sudan, what you see on this satellite image combinations. You see the first image from March 2022, which shows the normal light footprint of the city. And then the conflict started on 15th of April. So the first nightlight images on 17 and 18 of April see strong variations. So parts of the city, like the center, which was a hotspot of the conflict, but also the south, have been disconnected from the electricity grid. And that's a more recent situation where also large part of the center is disconnected from the electricity grid, with sort of scattered connectivity towards the south and also into the area here in the west, which is the Underman area, which has been also massively impacted by the conflict. We are now also looking, because these are very coarse resolution data, also there are new satellite like SDG-1sat, which provides higher resolution data, but not very frequent data sets for each city. We're also working on an Earth Explorer mission together with colleagues to hopefully convince ESA to build a high-resolution nightlight satellite to improve nightlight mapping, because it has many important aspects in terms of sustainability. In all this work, and particularly in all the projects we are running, we have a very strong user-centered approach, which starts with a co-design process. So we are not sort of building a product and then saying in the end, here users have and we sort of demonstrate the product and could try to convince users that this is relevant. But we start from the beginning to assess the needs and the user requirements at the beginning of various user communities, being it government actor, academia, the private sector, and also very strongly focusing on the needs of the communities, but also their concerns to have data publicly available. So within IDEAMAPS, we are building an ecosystem that allows modeling deprivation that responds to user needs at the local level, but also at the global level, to be also a platform of exchanging data. And that's one of the unique principles of our model framework, that we feed various data into our model, being it all Earth observation data, data coming from local authorities, citizens generated data. We first have the standardization and anonymization process to also deal with privacy issues, data control questions, of course. And then we have predictive model that allow us to produce deprivation models. We feed this model back to the user community, and we ask for validation and feedback, which go back into the flow of our model and have a continuous improvement cycle of the model. Data should be also related and relevant. So it should be overall models, but also data which showed a specific indicator and relating to sustainability challenges of specific data needs. And that's again, maybe my hobby, going to nightlight images, that shows this very beautiful energy transition of the city of Milan, where you see the increasing blue lights in the city center, which relates to the use of LED lighting, showing the energy transition, because LED lighting is more energy saving, where the outskirts are typically not have been making this transition so far. As you have been hearing, that a lot of the models we are building is combining Earth observation data with citizen data. And that's a work we are doing to see how much Earth observation data can be understanding and are able to capture this very deep ground knowledge of citizens. So what we did is we used image comparisons, and we asked a massive amount in workshops, communities living in deprived areas to compare all these image pairs and tell us which area is the better area to live. And we used this more than 1 million comparison of image pairs to train deep learning models that are able to predict the variations of living conditions in communities. We are sort of still in this process, also expanding this to other cities. But so far what we see is that only using Earth observation models, we can get to around 80% prediction of the variations of living conditions perceived by communities. Of course, you will never get 100% model, because there's also, of course, the data has also maybe some noise, and people also disagree, obviously, because we also had people comparing the same image pairs. One aspect of this variations of living conditions, and that's something which one of the environmental really urgent aspects for many communities to be solved, is the massive amount of garbage accumulation. Here mapped on the left side with basic land use, land cover classification system, and then on the right only highlighting the class of waste and the concentration of waste. And what you see is that this waste follows very much the drainage system of the settlement in Nairobi, which is very much meaning that waste are accumulating along the drainage, which is not only an issue, environmental issue, but a trigger also to increase the flood problem of this community, and a massive impact for health risks after a flood, because it's often human waste. It's very sort of contaminated waste which flows to the communities, and particularly small children are easily getting contact with this highly contaminated waste, leading to massive health challenges after a flood. So what we are doing is we are also experimenting and building sort of open data portals to help local actors to access data. Data like here in the case of Nairobi, we have been putting everything we did on Nairobi together in a data portal that allows users to view the variations of the overall degree of deprivation, relating it to the sort of an estimated population in each grid cell, but also looking to, you can switch on also other environmental factors like the waste concentration, etc., to view the specific problem. Now coming also to this interaction between deprivation and hazard. Most of the communities, they are not only impacted by one hazard, like here shown, also in one of the very serious floods in Nairobi. If you want to do this exercise, let's say a very great data product we are using a lot, which is the Global Human Settlement layer from the European Commission. But if you look to the city of Nairobi, you will see that the prediction is that there's 0% flood problem. If you talk with anybody in Nairobi, you will say there's frequent floods occurring. And this is not, let's say, it's an example of a flood which very frequently occurs, like settlements being seriously impacted by floods. And often you have settlements are also not impacted only by one type of hazard, but by multi-hazards. And we, I think, need to get to a close understanding how much people living in deprived areas are impacted by floods, by hazards, for example, floods, but also by other forms of hazard, and also the combination of hazards, which are often totally overlooked in global data products, in models, because it's very difficult to model particularly floods in such settlements because of their complexity, but also the data gaps which exist on those areas, which are not helping to produce, to acknowledge the massive challenges people already face, and they will face even further in future. Also the same issue, questions about landslides. Typically, the most deprived communities here shown in the case of the city of Mumbai, which is not a very extreme terrain, not like cities like Medellin in Colombia, but in all places we have been doing this analysis with colleagues from DLR. You see that the people living in the informal communities are more susceptible to landslides as compared to inhabitants of formal so informal communities are more susceptible to landslides as people living in formal communities. The same question about the increasing temperatures which we are facing on a global scale, and the question on how much more are deprived communities impacted, and they have also the least capacity because they don't have air conditions. They typically, and that's also what you see in this example we did with some communities, saying what indicators makes or defines an deprived area, and the top indicator was iron roofs. And the iron roofs, which are typically roofing material in many countries used for deprived communities, are the most, so it's like an oven, you live there under it, and which causes a massive amount of surface heat exposure. Of course, there are other examples, like this example in India and Bangalore we have been working, which is plastic tents. So it's not always deprived communities. We then now just starting project on ICANA together with my colleagues from ULB. We are looking into how much an Earth observation model capture these differences in temperature, and how does the temperature recorded from Earth observation system relates with the temperature experienced in communities. So what we are doing is we are combining Earth observation-based mapping of surface temperature with transect walks through deprived communities to see what is the pattern on the ground and the air temperature which people are exposed to in those communities, and relating this also to fixed measurement stations. This will be then also again related to our analysis of deprivation and the variations of deprivation for other aspects. So are the most deprived in terms of general environmental aspects, housing quality, etc., also those who are the most exposed to extreme temperatures. What we are doing, very snapshot, so we're identifying some of the hotspots on very coarse thermal images, and then this will be combined with transect walks and fixed measurement station, which we will implement for a couple of weeks in some of the communities to measure the air temperature variations during the day of those settlements and looking to the variations within settlements. So overall, what is our vision we are working on is building innovation hubs that are supporting data-driven sustainability strategies, looking to fair, just, equal, and inclusive urban communities, looking to also to the question on how we can develop local capacities, working with local researchers, also co-researchers from communities, to take them with us to the project and to the research, and also developing their capacity of working with data, responding to the future challenges, also being put in the position of being equal negotiation partners with local governments, towards supporting transparent and evidence-based policy making to deal with this massive sustainability challenges. Also in relation to this sustainability challenge and to make Earth observation data more accessible, refers also to this question on how to build trust on the models we build, because often the major comment, yeah, your models are very black box models, we don't trust them, we don't understand what is happening, why is the output like this? So I think we really need to invest much more in thinking about data quality, input data quality to our models, but also to make our models explainable to the users, because we just can't say, okay, this model predict A, I don't know why it predict A. So we need to be accountable also for what we are producing. And then I think we need to sort of share also, because many of, and my focus is very much obviously on Global South questions, but a lot of similar challenges are happening also not only in the Global South or in the low and mid-income countries, but also in the high-income countries, where you also have often very unequal urban systems, and a part of the population lives in very deprived, physically and also environmentally deprived areas. What we're also doing with a recently started project, which looks to the climate vulnerability of deprived communities, where we very strongly emphasize so this intersection between climate, Earth observation, based mapping, but also to have the citizen science component, and also the sort of the idea of co-researchers, but also the communication, science communication, and making data transparent and trustworthy for users as a major challenge of producing relevant data to support global to local sustainability challenges. So in a nutshell, so what sort of our larger vision is on our innovation platforms, hubs, is to promote the, yeah, if you want to say a buzzword, smart cities, but more maybe looking to sustainable communities, safe, resilient societies, to use data to open a debate about future challenges, decisions, adaptation measurements, resource allocation, which is often very sort of limited in many cities, to do a more smart allocation to the most vulnerable parts of the cities in terms of what are the most urgent challenges, which is often not clear because of data gaps of local stakeholders, but also using data for accountability and the motivation of behavioral changes of local actors, being it on aspects of crisis and rapid actions, visualizing sustainability trajectories, making data accountable, using data for accountability to show the variations of living conditions, and to motivate local actions, and to have a global, more relevant data set to promote global discourse and action towards global sustainability challenges. So thank you, and looking forward to your questions. I'll stop my presentation. I'm happy also to share my presentation as a link if you like to have it later.
You can send it to me and I will provide the presentation to the audience. Thank you, Dr. Kuffer. Very interesting to see your work in Africa, and I've already received some questions privately in the chat. So while I read these questions, the rest of the people can type their questions in the chat, of course. So starting with the first question is by Dr. Kyriakos Neokleos from our team. Would it be possible to provide some information about the funding schemes you used so far? Because we saw some funding schemes that are not the, let's say, traditional funding schemes for our team. So I guess this is the reason we are interested in this.
So we have, let's say, so we have various funding, and the funding is always the struggle for any researchers. You have brilliant ideas, but then sort of you need also a team to implement, and you need to get some younger researchers in PhDs, postdoc positions. Indeed, that's a big challenge. So we had like also starting with a frustrating kind of frustration experience. So we started with IDEAMAPS, and we had a UKRI grant from the UK together with colleagues of the UK and partners from Africa. And then because of the Brexit and the reduction of funding which goes to outside the UK because of the very nationalistic policy of the UK, we were entitled for a second round, and this was stopped. So we had massive challenges to deal with it. So we were sort of marketing, and we got Bill and Melinda Gates Foundation interested, and so that's luckily we got a new grant from them. So it's really a lot of networking there, which was necessary to sort of get them interested. Other grants in the moment are from the European Space Agency grants we're having. We have educational grants, which are from a Dutch grant scheme, which is on capacity development, which is NUFFIC. We have also grants from National Science Foundation of the Netherlands, which are NWO grants. I think these are the major grants we have at the moment.
Mm-hmm. Thank you for the answer. And if I may go to the next question, can your approaches be applied to different environments, or will this require also in situ datasets for each region? So can your approaches, let's say, use only satellite data, for example?
In principle, that's what we're experimenting in it with it now. I don't have a final answer to this. We hope yes. So we are now developing very thorough models, and that's our sort of approach. So we're developing very thorough models in several African cities. We're also doing some tests across the globe in a moment on cities outside Africa, like in Latin America, like in Buenos Aires, in Medellin, in Mexico, and Salvador, Brazil, also in Asia, in Mumbai and Jakarta, to see how far we can get with Earth observation alone data. We are thinking about, can we cluster, and that's always the issue of transferability of Earth observation-based models. Can we cluster cities according to morphological groups to predict transferability and put models into groups which support transferability? But we don't have a final answer, but we hope yes.
Nice, interesting. I don't see any further questions in the chat, so if anyone else has any question, you may also raise your hand if you want. So I will just wait some couple of seconds to make sure there are no further questions. So there's another question. How did you detect waste and do you classify it?
So basically, we have been doing this waste classification in several cities so far. It's possible. We have been using so we have been starting with very high resolution data sets. So we have been using worldview data, which is of course not towards scalability. So we are now looking into how much and how better Sentinel data can predict the larger waste accumulation. Of course, often you have very small waste piles, which are like maybe 1-2 meter max. And you would need to see whether some kind of signal would be in a 10-meter pixel be possible of a Sentinel data set, which would be a bit of a tricky prediction. So, but we are looking also how much can we use also Sentinel data to predict the waste accumulation, because in the end, you would like to have a global map. So a global map showing the massive waste accumulation across, or also a continental map, Africa. It's one of the prime examples. Wherever you go, it's shocking. I don't know if you ever, for those who have never been to a city in Africa, the amount of waste is truly shocking. And you basically, I remember going in the direction of Khartoum before the conflict, and you see in Sudan, each city, you can see the traces of the city before you even see the silhouette of the city, because the waste is because of the wind and the desert climate. You see the traces of the city before, with the waste footprint, before you see the city.
So thanks for this.
And it's basically, we are doing, it was done with object-based detection in the very high resolution images, but we are also now working on deep learning models to predict the waste accumulation.
Thanks a lot. So if there are no other questions, then I would again like to thank you for today's talk, Dr. Kuffer, and of course all the participants for joining us. We will be sharing the recorded video with you later on today or tomorrow, and we will inform you shortly about our upcoming invited talk via email. Also, the presentation of Dr. Kuffer will be also included in the email. Thanks for joining us and enjoy your day.
Thanks a lot for having me, and thanks a lot for listening too. And let me know if you have questions or interesting insights, and I'm very happy to get in contact.
Sure.
Have a good afternoon.
Bye.